Hi everyone. Today we're going to be talking about the idea of solving systems in a new method. The new method is going to be called substitution. So go ahead and follow along with your notes and copy down what I'm writing. We can solve systems in different ways. One of these methods is substitution. Use substitution by following this process. Substitute equal values. Okay, that's step one. Step two, solve for one variable. And finally, step three, substitute that value into one of the equations and solve for the other variable. Remember, we're looking for an answer that looks like x comma y, a coordinate point. This is what we've been talking about for a couple weeks now, just a different way of doing it. So now the whole idea behind substitution is just like another substitute. Let's say you were playing a sport like basketball and you substituted in someone. That means that you replace someone with the same position. So here we go. We're going to use that idea to solve these systems of equations. Okay, here's example one. Now in this example, what I'm looking for is either equation that has y or x alone. So I see an equation that says y equals x minus 1, and another equation that says 2x minus 3y equals negative 1. Here, I notice that y is alone. It's by itself on one side of the equal sign. So in that case, I can actually use that equation to sub into the next equation. So again, we're going to be using this idea. If y is equal to y, right, then I can replace one value of y into the next value of y. Okay? So basically what I'm going to be doing is I'm going to be taking this x minus 1 because it is equal to the green y, and I'm going to put it in, or substitute it in for this red y in the second equation. So all I'm going to do is write the second equation. 2x minus 3y equals negative 1. But now, instead of y, I'm going to be writing x minus 1 in for this y. So I'm going to write 2x minus 3, and then in parentheses, right, because 3y, that means 3 multiplied by y, so I'm going to put parentheses. I'm going to write x minus 1 from over here, and then continue my equation equals negative 1. That's the big idea behind this. Whatever the variable is that's by itself, I can substitute it into the second equation to be able to solve. So now I just have a multi-step equation. So I'm going to rewrite it just so you guys can see it more clearly. 2x minus 3 multiplied by x minus 1 is equal to negative 1. So now I use the properties that I already know how to use. I see the distributive property, this number outside of parentheses, so I'm going to multiply negative 3 by x, then negative 3 by negative 1. So I'm going to bring down the 2x, negative 3 multiplied by x makes negative 3x, negative 3 multiplied by negative 1 is positive 3, equals negative 1. Okay, so I'm still splitting my equal sign all the way down. Now I look at my left side, I have some like terms. I see 2x and a negative 3x. So if I combine those become negative 1x. Bring down my plus 3 equals negative 1. Going to keep going, use some inverse operations and zero pairs here. So I see this add 3, so instead I'm going to subtract 3. That creates a 0. So now I've got negative 1x equals negative 4. Now the only thing that I have left to do is to do the inverse operation of multiplication and divide. So now I've got x is equal to positive 4. So again, if I've got part of my answer x comma y. Now I need to figure out my y value. So just like how we learned last week with the equal values method, I'm going to take this x equals 4, and I'm going to replace it into either equation. Again, I like the top equation, so I'm going to write y equals x minus 1. But instead of the x, I'm going to write 4. So y equals 4 minus 1. So y is equal to 3. And that's my final answer, 4, 3. Okay. Again, I know that this seems a lot of work. Seems like a lot of work, but the whole idea is just substituting in this original x minus 1 into this equation. Okay. Now, example 2, the only difference here is that we're going to see x alone. It says x equals 2 minus y. Second equation says negative 5x minus 4y is equal to negative 2. So in this situation, I see x alone. So in that case, I'm going to replace x. So I'm going to rewrite that second equation. Negative 5x minus 4y is equal to negative 2. But instead of the x, I'm going to replace what x is equal to, which is really 2 minus y. So I'm going to write negative 5, parentheses, remember because we're doing multiplication, 2 minus y, minus 4y, just copying over here, equals negative 2. Just copying this down, but instead of the x, I'm writing what x is equal to, which is 2 minus y. So now I can distribute and start solving. So negative 5 multiplied by 2, and negative 5 multiplied by negative y. So negative 5 multiplied by 2, that's negative 10. Negative 5 multiplied by negative y, that's positive 5y. Subtract 4y equals negative 2. Split my equal sign. See if I have any like terms. I notice that I see positive 5y and negative 4y. So I'm going to write negative 10, and I'm going to combine these, which makes 1y, and bring down my negative 2. Okay, so now I have non-y's on my right side, so I want to get other non-y's with it. So I'm going to add 10, make a 0 pair, add 10 here. So that makes 1y is equal to positive 8. Which is really just y is equal to 8. Okay, so in this case, I actually figured out my y value first. So my y value goes second. I figured out my y value. Now that I have this, I can use either of these equations to substitute it back in. Again, I like the top equation because the x is alone, so I don't really have to do much solving. So I'm going to rewrite this. X is equal to 2 minus y. So now I'm going to replace this 8 for the y. So that'll be x equals 2 minus 8. Now it's x is equal to negative 6. So that's my x value, and that is my solution. If you graph these two lines, that would be the point where they cross, negative 6, 8. Okay, so let's move on to the next couple of examples. Okay, example 3. So I see 5x minus 2y equals 3, and y is equal to 2x. Again, I ask myself which one has a variable by itself. I see that y equals 2x has the variable by itself. So what I'm going to do is I'm going to substitute in this y, right, because this is equal to y. I'm going to substitute it in to the top equation. So let me rewrite the top equation. 5x minus 2y equals 3. But instead of y, I'm now going to write 2x. Okay? Now remember, the whole idea is that you're actually replacing it. So don't rewrite y. You replace the y, it completely disappears, with 2x. equals 3. So now I've got 5x, and now I'm going to multiply negative 2 by 2x. That makes negative 4x, which is equal to 3. I can combine like terms. I see 5x minus 4x, or negative 4x, however you want to think about it, and that's 1x equals 3, which is really just x equals 3. Okay, so again, now here I figured out my x value, and I still need to figure out my y value. So this equation looks a little simpler to substitute in, so I'm going to rewrite that. Y equals 2x, but instead of the x, I'm going to write a 3, because that's what I figured out with my first equation. So y equals 2, in parentheses 3, so that means y is equal to 6. And that's how I figure out my solution. Again, the whole point of this is that if I didn't want to graph these, I could find the point where they cross using algebra. Okay, here's example 4. You want to be careful on example 4 because you're going to have this negative sign to deal with. Okay, so I see negative x plus 3y equals 2. None of the variables are by themselves. The second one says x equals 2y plus 3. The x is by itself, so since x is by itself, that's where I'm going to substitute into the other equation. So I'm going to take this 2y plus 3, I'm going to put it in for this x. So let me write that out. So it's negative x plus 3y equals 2. Now watch this. I'm going to write negative, but then I'm going to write a set of parentheses to be able to plug in the 2y plus 3 plus 3y, just copying down what I see up here, equals 2. Continued copying. Okay? Now this negative in front of the parentheses is like a negative 1, so I need to multiply negative 1 into the parentheses. So that becomes negative 2y, negative 3, add 3y, because that's out of the parentheses, I'm not multiplying it, equals 2. So now I find my like terms, if I have any. I notice I have positive 3y and negative 2y. If I combine those make positive 1y minus 3 is equal to 2. Now I use some zero pairs to get the y by itself. So I'm going to add 3 here. This makes 0. So now I've got 1y is equal to positive 5, or just y is equal to 5. Okay, so now that I figured out one variable, just like my process tells me, I'm going to substitute it in to be able to figure out the other variable. So this one with x by itself might be a little bit easier to substitute in, so I'm going to write x is equal to 2y plus 3. But again, instead of this y, I'm going to write 5. So x is equal to 2 multiplied by 5 plus 3. And here I just use my order of operations. 2 multiplied by 5 is 10 plus 3. So x is equal to 13. So my x first is 13. My y value second is 5. The point at which these two equations intersect is 13, 5. Alright, this would be a good place to pause. Try the next two examples on your own, and then check to make sure that you got them correct. I'm going to do these relatively quickly. So example 5 says 5x minus 4y equals negative 3. Second equation says y equals negative 3x plus 5. I see that this y alone is alone, so I'm going to take this value and substitute it in for y. So let's go ahead and do that. 5x minus 4y equals negative 3. I'm going to replace y with this blue equation right here, 3x plus 5. And just keep copying equals negative 3. So now I'm going to use my distributive property, multiply the negative 4. Don't forget that sign before the 4 to be able to multiply correctly. So 5x Just going to bring that down. Negative 4 times 3x is negative 12x. Negative 4 times positive 5 is negative 20 equals negative 3. Don't lose your equal sign along the way. I see my like terms. I'm going to combine those. Those make negative 7x minus 20, just brought that down, equals negative 3.